Good afternoon, everyone. Now, today I am going to start the numerical problems based on determinant. Last class or last video we did the applications and the properties of determinant. Now, today we are going to solve using the property. We are going to solve the numericals. Now, say the first numerical. The chapter name is determinant. The question is prove without expansion. That means if the question is prove without expansion, we cannot use expansion method. Using some other properties that you have to prove, this determinant is equals to 0. Now, the question is over here 1, 1, 1, x, y, z, y plus z, z plus x plus y equals to 0. Now, without expansion method that you have to prove, using the properties only that you have to prove, this determinant is equals to 0. Whenever you will say the determinant is equals to 0, always try to remember the property. If any two rows or any two columns of a given determinant are identical, the value of determinant is equals to 0. That means to prove this identity, prove without expansion, this identity is equals to 0 means you have to use property. You have to make any two rows or any two columns of the given determinant is identical. Now, I'll take left hand side and I'll try to make any two rows or any two columns of a given determinant identical. Now, this one is left hand side. Now, this one is first row. For few numericals, I will write these things, but in examination, you are not allowed to write all these things. But to make you clear, I am writing these things. R2. Now, this one is column 1, this is column 2, and this one is column 3. Now, say this one is rows, row 1, row 2, row 3, and this is column 1, column 2, and column 3. Now, I'm just trying to, I'll try to make any two rows or any two columns identical. Now, say I'll add these two quantities. I'll add C2 plus C3, then I'll write C2 prime. That means I'll add these two columns, column 2 and column 3. Now, after addition, column 2 is going to change over here. Now, then this is equals to, if I add these two quantities, then 1, 1, 1. If I add these two, what will get? X plus y plus z. This is C2 plus C3. Then I'll add these two quantities. This one will be x plus y plus z. If I add this two, the second one, if I add these two quantities, what will get? Y plus z plus x. We can write x plus y plus z. Then add this two, you will get, if I add these two quantities, you will get x plus y plus z. Now, the third column will remain same, y plus z, z plus x, and x plus y. Now, one more property that I am going to use, the common can be taken from a single row or from single column. Now, from the second column, I'll take x plus y plus z common, taking x plus y plus z common from C2 column 2. If I take this quantity common, then what remains inside the determinant? It will be x plus y plus z within bracket 1, 1, 1. If I take common, then what remains over here? 1, 1, 1. Then y plus z, then z plus x, and x plus y. Now, say over here, after taking common, first column and second columns are same. Same means these two columns are identical. if any two rows or any two columns of a given determinant are identical, the value of a determinant is equals to 0. This one will be 0. X plus y plus z into 0 is 0. This is equals to right hand side. Now another question, question number 2. For this question also I'll take left hand side. Left hand side is 1 1 1 minus a minus b minus c, b plus c, c plus a plus b. Again for this numerical I'll write this is R1, this is R2, this one is R3. This is column 1, column 2 and column 3. In this sums also, this determinant is equals to 0 that you have to prove. Now for this only, for this question also, I'll try to make any two rows or any two columns identical. How to make these things identical? Already 1 1 1 is given. In some one more column, I'll try to manage 1 1 1 over here. To make it 1 1 1, now say, if I subtract these two, let us suppose C3 minus C2, then I'll write C3 prime. After subtraction, the column 3 will change. Now, if I subtract this, B plus C minus of minus A will be, then it is 1 1 1, second column will remain same, first and second same. If I subtract B plus C minus of minus A, this one, then we'll get what we'll get? A plus B plus C. Similarly, if I subtract this two, we'll get A plus B plus C. Now then, subtract this two, then A plus B plus C. Once again, I'll use the property taking common from taking A plus B plus C common from C3. If I take this A plus B plus C common from C3, then what will get? A plus B plus C within a determinant will have 1 1 1 minus A minus B minus C, and this one will be 1 1 1. Now in this case, now say first column and the third columns are identical. If any two rows or any two columns of a given determinant are identical, the value of a determinant is equals to 0. This determinant is equals to 0. 0 into A plus B plus C is 0. This is equals to right hand side. Now another question. Now this question is a little bit different question. This is 1 omega omega square 1 omega square 1 omega equals to 0. The elements of the determinant are in terms of complex number form. Now you might have done these things in class 11, complex number. Now omega are called 1 omega square are called the cube roots of unity. And the properties of complex number, the cube roots of unity, sum of the cube roots of unity equals to 0, and product of the cube roots of unity, like 1 into omega square, what will get? 1 into omega square is omega cube, and the value of omega cube is 1. You just have to remember these things. Omega cube is 1. Now say, now over here also the determinant is equals to 0 that you have to prove. Now I'll try to make any two rows or any two columns identical. Now say, I'll multiply any rows or any column by omega. Now we did in property, if you multiply the determinant by any constant quantity or any other quantities with the same constant quantity, you have to divide the determinant. Now say, multiply and divide by omega. I'll first divide the determinant by omega, now then I'll multiply. Now I'll multiply, divide by omega means, now I'll have to multiply by omega. I'll multiply R1 by omega. If I multiply this R1 by omega, then what will get? If I multiply this one, multiplication takes place only in one row or in one column. You can multiply only one row or one column. If I multiply this one by omega, then omega, it will be omega square and this is omega cube. Now other two rows will remain same, no need to multiply. Now then, I'll substitute the value of omega cube over here, 1 over omega, then omega cube is 1. So omega is square and omega cube is 1. Now this one will be omega is square 1, omega is square 1 omega. Now say over here, these two rows R1 and R2 are identical. Omega is square 1, omega is square 1. These two rows are identical. The row 1 and row 2 are identical. If any two rows or any two columns of a given determinant are identical, the value of determinant is equals to 0. So it is 0. This is equals to right hand side. For this question, you just have to remember the omega cube is 1. For this question, I'll take left hand side, 1, 2, 3, 1 square, 2 square, 3 square, 2 square, 4 square, 6 square. This is equals to 0 that you have to prove. Now say first of all that you have to simplify the given elements. Then I'll try to make identical. 1, 2, 3, and then 1 square is 1, 2 square is 4, 3 square is 9, 2 square is 4, 16 and 36. Now in properties we did these things. Common can be taken out from a single row or from a single column. So I'll take 4 common from column 3, taking 4 common from column 3, taking 4 common from column 3. Common can be taken from a single row or from a single column. This property I am using over here. Now the first two column will remain same, 1, 2, 3, 1, 4, 9. Then if I take 4 common, then this one will be 1, 4, 9. Now so we also, the second column and the third columns are identical. If any two columns are identical, the value of a determinant is equals to 0. 4 into 0, 0, which is equals to right hand side. It is proved. Now this question is a little bit different. Determinant is equals to determinant. You don't have to prove this is equals to 0. Determinant is equals to determinant. Now in this question I'll use other properties also. Not only identical properties, other properties also that you have to use. A, B, C. B, C, C, A, B. Now this second determinant, right hand side determinant, it contains A square, B square and C square. But over here it is A, B, C only. How to get A square, B square, C square? Now then, I'll multiply this row 1 by A, row 2 by B and row 3 by C. Multiplying R1, R2 and R3 by A, B and C. Multiplying R1, R2 and R3 by A, B and C. Now if you multiply by any other constant quantity, means with the same constant quantity that you have to divide the determinant. That means now I am going to divide the determinant by A, B, C. Now then I'll multiply. The first row that you have to multiply it by A. It will be a square ABC. Second one, you have to multiply it by b square ABC. Third by c square ABC. Now then I'll take common, ABC common from column 3. Now I'll taking ABC common from C3. Common can be taken out from a single row or from a single column. Now if I take ABC common, then it will be ABC A square B square C square. This one will be 1 1 1, and this ABC get cancelled over here. Now say the right hand side is a little bit different. Now say 1a square, 1b square, 1c square, but we have a square, 1b square, 1c square, 1. Next I'll use property. The next property is, if you interchange two adjacent rows or two adjacent columns of a given determinant, the value of determinant will remain same, but the sign will change. The interchanging property of determinant. Now say the position of this 1 1 1 must be over here. Then I'll interchange these two quantities. Column 2 is replaced by column 3 and column 3 is replaced by column 2. Now what is the sign of this determinant? It is plus over here. If you interchange these two quantities, then the determinant will be A, B, C. Then if you interchange these two columns, then this one will be A square, B square, C square. Over here it is plus. After interchanging that, you have to write minus. If you interchange row into the column or column into the row, the value of determinant will remain same, but the sign will change. If it is plus, means that you have to write minus. Again, the position of the 1 is over here, column 1. Again, I'll interchange these two. Column 1 is replaced by column 2 and column 2 is replaced by column 1. Then if I interchange 1 1 1 A B C, then A square B square C square. Now in this determinant, it is negative. After interchanging, this one will be positive. You have to change the sign. Now the left hand side, this is equals to 1 A square, 1 B square, 1 C square. We have this quantity over here. This is equals to right hand side. Thank you.